Next, let's talk about probability distribution. It is a function that describes how likely you will obtain the different possible values of the random variable. In other words, it's the probability of the different possible values for the random variable. Similar to random variables, probability distribution also has two types, discrete and continuous. A discrete probability distribution is a function that is created for an event that has countable outcomes, and each outcome is represented by a bar of data in a bar graph. Each bar of data represents the probability of each outcome, and the sum of the probability of each outcome in the event will always equal 1. A continuous probability distribution is a function that is created for an event that has an infinite number of outcomes. Since the outcomes are infinite, a sum over such a set of numbers is not possible because the outcomes are uncountable. Instead of finding the sum of the possible probabilities, we find the area under the curve using integral calculus. This type of calculation is beyond what is required in the course, so it will not be covered here. Here's an example for probability distribution. The random variable t is defined as the number of tails after a fair coin is flipped 4 times. Find the probability distribution for capital T. Draw a graph of the probability distribution. We'll begin by finding and writing out the possible outcomes that you have. You could have 4 heads, you could have 3 heads in a row and then a tails, you could have heads, heads, tails, heads, heads, tails, heads, heads, tails, heads, heads, heads. You could have heads, heads, tails, tails, heads, tails, heads, tails, heads, tails, tails, heads, tails, heads, tails, heads, tails, tails, heads, heads, tails, heads, heads, tails, 3 tails and a head, 2 tails, a head and then a tail, 1 tail, 1 head, and then 2 tails, 1 head and 3 tails, or 4 tails in a row. And those are all the possible outcomes for that could occur here. Next, determine the probability of each type of outcome. So when the probability that tails is equal to 0, or the probability that no tails are obtained, well, that only happens in heads, 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 one outcome. So therefore, the probability that t is equal to 0 is 1/16. Next, we're going to find the probability that the number of tails is equal to 1, or the probability of flipping only 1 tail happens. Well, it definitely works in this outcome, this one, and this one. So that's 4 out of 16, which reduces to 1/4. Now let's look at the probability for t being equal to 2, or the probability of flipping 2 tails. Well, we can see in our outcomes that 2 tails happen 1, 2, 3, 4, 5, 6 times. So it's 6 out of 16, which is equal to 3/8. Now let's look at the probability of getting 3 tails. So we have 3 tails starting here, 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 and here. There are 4 outcomes out of 16, which reduces to 1/4. And then the last outcome is the probability that the number of tails is equal to 4. Well, that only happens in one outcome, the last one. So the probability of it occurring is 1 out of 16. So what we have found is the probability distribution for event t, the number of tails occurring when a coin is flipped 4 times. The probability that tails is equal to 0 is 1/16. The probability that 1 tail happens is equal to 1/4. Probability that 2 tails happen is 3/8. The probability that 3 tails happen is 1/4. And the probability that 4 tails occur is 1 out of 16. So if we draw a graph to represent the information that's been found, for 0, we have 1/16. So our bar would go about this high. And then for t is equal to 1, that was 1/4. For 2, it was 3/8. So that's up here. For Probability that the tails was 3 is 1/4 again. And the probability that there were 4 tails is 1 out of 16. And the graph will look something like this, which does represent the graph that we drew on the last slide. Let's try another example. Abad is running a restaurant and wants to learn more about his customers' choices. Abad collects data on 8 tables of 3 people and marks down if each customer ordered an appetizer or not. The data that was collected is given in the table to the left. Y represents yes, they ordered an appetizer, and N represents no, they did not order an appetizer. Draw a graph of the probability distribution for the number of appetizers served at the table. All right, so in this first table, we have yes, yes, and a no. So therefore, we can tell that 2 appetizers were ordered at this table. In table 2, it was no, no, and yes, so 1 appetizer was ordered. At table 3, we had a yes, no, and a yes, so 2 appetizers were ordered. In table 4, we had 1 appetizer ordered. 5, we had 0 appetizers ordered. At table 6, 3 appetizers were ordered. Table 7, we had 2 appetizers ordered, and table 8, 0. So out of the 8 tables that we have at this restaurant, during this time, 2 of them had 0 appetizers ordered. So 2 out of 8 is 1/4, or 25%, or 0.25 as a decimal. So this would be the bar that takes care of zeros. Okay, now let's look at 1. We have 2 ones. So again, that is 1/4 of the data, or 2/8 of it. So those are taken care of. Okay, so 1, 2, 3 tables ordered 2. So that's 3/8, which is 0.375, which is halfway between 1/4 and 1/2. So it's 3/8. And then that takes care of the 3 2s. And now we have 1 table that ordered 3, so that's only 1/8, or 0.125, and that represents this bar. And the graph that appears here to the right does resemble the graph that we drew to represent the appetizer decisions made by the guests or the restaurant customers at the 8 tables.